to my YouTube channel. Today I will provide digital electronics top most expected question. So now let's start. Question 1. A three variable key map is as given below. Then solution of the key map will be. So for its minimization I will first making the group and then group I will take the variable corresponding to group. So these are the equation I get. So for this one there are three equation I get. So option A and B and D are correct for this one. Now next one is a logical circuit is implemented as shown. These are the logical circuit with 10 nanosecond delay, and for NOT gate 20 nanosecond delay, and for XOR gate 10 nanosecond delay. So initially we provide the input 1 and output also gives 1, but after that we will provide A and B are changed to 0. Then it will ask for how much time it will give 0 at output Y. So for this, after 10 second it will, if I convert this 1 1 to 0, then after 10 second it will here also 0, this point after the AND gate, and here after 20 second 20 nanosecond uh, 1 gate. So it will after 20 nanosecond from here we will get 1, and before it gives after only 10 second. So there is a difference between 10 nanosecond. So 10 nanosecond, so it will ask when, how much, what is the time when t1 time when gives 0, and 2 up to what time means kab tak t2. So it will up to 30 nanosecond, it will start from t1 20 nanosecond to t2 30 nanosecond. It will show 0. You will, I will explain here, you will also read this. So 20 to 30 nanosecond it will show 0, so total 50 nanosecond. Now next one is a serial in parallel out register circuit is as given below. So these are the initial state. When you apply clock, there is a AND operation and there is a NAND operation. So after performing these operations, first clock it will get this. After AND operation Q2 and Q3, and then the AND operation Q1, and then get NOT, I will get 0. So here 0 we will get, and then 0 is shifted towards first Q1 Q naught place. So it will shifted towards. So after 6 clock cycle I will get same state. So for this question answer is 6 clock cycle. Now next one is the mean term expansion of this PQR is. So for this question I will first draw the K-map by using these variables. So these are, put the 1 at the place of variables groups, then I will get 2 4 6, these are the min terms, it will ask for min terms, then for this is the answer for question 4. Answer E, option A is correct. Now next one is question 5. What is the minimum number of gates required to implement the Boolean function AB plus C if we use 2 input NOR gate? So for 2 input NOR gate, I will convert first into in NOR gate structure. So for this I will first um, first I will differentiate, distinguish them, a plus c and a plus b. Then after I will get not, I will apply um, not De Morgan's law. Then I will get this. Then now I will apply NOR get easily. So for this one is one NOR get, and for this one or more, and then for whole one more also. So three NOR get are required. So for this question is answer is 3. Now next one is, what is the minimal form of Karnaugh map shown below? Assume that X denote a don't care term. So it will ask for minimal term. So I will make the first group of the Karnaugh map. First four group of four corner, and then one for this one. So after performing the group operation, I will get these variables. So for this question is answer is BD and B bar C bar. Now next one is given F1, F3 and F is canonical function of products formed in decimal for this circuit. So for this one is I will solve. Here is F1 and F2 AND operation. AND means both are same, then its output will be forwarded. And in F3 this is a union like structure. So for F2 I will get at F this variable 16815. So 1 and 6 and 8 and 15 are contained by the F1 F2 operation and F3 operation. So F3 contain 1 6 15, 8 does not contain, so should be here 8 present in F1 and F2 operation. So it will ask for F2, so and then F2 will contain 8. So F2 may be B C D but not 4. But not there is not 4. So here 2 does not contain 4. So no, not B, not D, only C is correct. So for this question I will solve in this way. Now next one is, if PQR are variables, then simplify. For simplify, I will perform this operation. First we multiply this, and then second, then after this multiply, and then I will get PQR. So in this way I solve this one. Now next one is question 9. This is the Boolean combinational logic circuit NOR gate operation. For this question I will solve by this way. First we will take P plus Q ka whole bar, and then Q plus R ka bar, and then the whole bar of this, and then after performing this one also. So then after I will get whole bar of these operation, and then after performing these operation I will get Q plus R bar. So for this one is Q plus R bar option A is correct. Now next one is question 10. Control inverter, a circuit that can add 3 bits, a circuit that can add 2 binary number, full adder, half adder, a logic circuit that adds 2 bit. Half adder is 2 adds 2 bit, so C goes to 4, and and D binary adder 2 binary numbers, D goes to second, D goes to second. So option 4 is correct for this one. So option D is correct. Option D is correct for this question. Now next one is Question 11. A ROM is used to store the table for the multiplication of two 8-bit unsigned integer. The size of ROM required is two 8-bit unsigned number. It means 8 into 8, 16-bit for storage for one number, and for multiplication up to two numbers, then we will get 2 e power of m into n, 8 into 8 into 2 into 8. So I will get 2 power of 16, 64k into 16. For this one is option D is correct. Now next one is question 12. Consider the circuit in the below. So this is the circuit. It will ask for what will be the um, minimizes after minimization, what will be the variables we will get. So after performing these, I will get this operation. Now it will be simplified. I will get A XOR B XOR C. So for this question is option C is correct. Now next one is question 13. When two n-bit binary number are added, the sum will contain at the most n plus 1 bits. If we add the sum of n-bit binary number, then we will get sum n plus 1 bits. Now next one is, if half adder and full adder are implemented using gates, then for the addition of two 17-bit number using minimum gates, the number of half adder and full adder required will be, for 17-bit number, for addition of two 17-bit number, we will get one half adder and 16 full adder. So one half adder and 16 full adder. So for this question is option C is correct. Now next one is question 15. In the sequential circuit shown below, if the initial value of output Q1, Q0 is 0, 0, what are the next four values? For this one, I will perform this 0, 0 for initial, and then it will give clocks and 1 bit for toggle. So it will change the q naught value, so it will toggle 0 1, and it this one is also go for this toggle, and there is also one, so it will also change the q1 value, so it will change q1 1 1, and then next clock one is it's of again toggle q0 to 1 0, and now keys, no, no, sorry, q something, no, it's correct. So it changed. Now again it's toggle 1 0, and then if 1 0, then here is 0, then it does not toggle, then in its previous value hold, so it will hold, and then again it's toggle q0 0 1, and then if it is 1, so it will again toggle 0 1, and it's again in next clock cycle it again toggle, but here is 0, so again hold the initial value. So these are the four states. So for this question, mm, option A is correct. Now next one is, the functional difference between SR flip-flop and JK flip-flop is that JK flip-flop is faster than SR. JK flip-flop has feedback path. JK flip-flop accept both input once. This is true. Option C is correct for this one. Now next one is, A modular 12 ring counter requires a minimum number of flip-flop. 12 flip-flop it's required. For this one is option B is correct. Now next one is, in a positive edge trigger JK flip-flop, if J and K both are high, then output will be on the rising edge of the clock toggle. If both are 1 1, then it will toggle the value. Now next one is, for this one is option D is correct. Now next one is, the number of flip-flop required to design a modulo 272 counter is. So for this one I will get mod 272, I will get log of 272, then I will get 9. So for this question is option B is correct. Now next one is, the characteristic equation of an SR flip-flop is given by, this is asked for characteristic equation. So for this one is S dash Rn S plus R dash n. For the SR flip-flop characteristic equation, option D is correct. Qn plus 1 is equal to S plus R dash Qn. Now next one is, the smallest integer that can be represented by an 8-bit number in 2s complement form is. So it will ask for smallest number in 8 bits, so 1 bit for sign and 7 bit for operand. So in 7 bit I will take in 7 bit 128 value, so I will get minus 128. This is the smallest number which will put in 2s complement in 8 bit. So for this one is option B is correct. Now next one is, P is a 16-bit signed integer. The 2s complement representation of P is this. The 2s complement representation of 8 cross P is. So for this one is, I will do this method. First I will convert in binary number, and then I will get its value in decimal value, and then multiply by 8. I will get minus 150. Then I will first 1540 in binary, and then complement of it in 16-bit, and then complement of it, and then plus 1. I will get minus 1540 into S complement, and then convert in hexadecimal. So I will get C3D8. C3D8. So for question 22, option A is correct. So these are the most expected and previous year question for digital electronics. So for later update, please comment, follow and subscribe my channel. Thank you.